Hi guys, welcome to this my combined mathematics or advanced mathematics YouTube platform. Day by day workouts very useful to practice your theory part by solving these revision type questions. Study theory properly and practice more and more problems for future any exams, advanced level, combined maths, applied maths, pure mathematics, at Excel, Cambridge, AS2 level. Any type of solving here mostly in integrations, algebra, trigonometry, probability. You see, I have shown given two problems involving one is integration and algebra. Okay, check your solutions now. Always best you tried maximum your that focus this problem and find out a solution. Come back to this and see how I am solving this, and then you know the technique. Maybe mine too long or you short, but I try to show well explanations to catch the what the marking scheme solutions. Okay, actually this problem depending the boundaries also 1 over 9 to 8 over 9, right? I will take this I equal. So such a problem comes better if they ask some theory part initially as a first A part 1. You know King's rule of King in integration. King's rule is state that function A plus B minus X f of integrate respect to X can shown as f of X dx, right? But the boundary is A plus B. Here A plus B, very interesting King's rule. It's called in international mathematics, pure maths, the rule called the King's rule. We can prove also some exam papers past our Sri Lankan combined mathematics. They asked to prove this simple. Now I want to go to prove. I want to show the proof straightly. Apply King's rule here. A plus B minus X can state that without A plus B fx. So what is A and B? They the two boundaries. So here 1 over 9 for A, 8 over 9 for B. Therefore, I can write that function is x4. We can explain x4 A plus B minus X. x4 A plus B minus X. So therefore, A plus B 1 over 9, okay, 8 over 9, okay, and minus X. 9 over 9 minus X. What is that? 1 minus X. Therefore, my dear students, that's the tricky of this question, challenging part. All my problems are internationally valid question as our national exams too. X4 say 1 minus X. X4 is for any mostly power comes. I always show that I am working for not only for this paper, this question, similar type come in the future. 3 to the power something or 7 to the power, like any, you think about this King's rule, right? Therefore I use this I equal. I take number 1 first equation. So I rearrange the I once again. Integral boundaries 1 over 9 to 8 over 9, okay, and 25 to the power not X, 1 minus X, right? Refer your King's rule theory in the theory class. 5 plus 25 power 1 minus X, right, into dx. Okay, now we continue in this process, simplify and try to evaluate the answer. You know this definite integration, we have a unique solution, numerical constant answer. Okay, you know some what we called indices format. What is indices rules? Primary class mathematics. Can I write this 25 into 25 power minus X? The bases are equal at the power. So 1 minus X. Okay, over 5 plus this 2 I can write 25 into 25 power minus X into dx. So why I shown this negative power? You know, we won't write the negative power. We won't write the negative power form. They are to try to remove this negative part. So you can multiple up and down or divide by this. Divide up and down by numerator, denominator, numerator, denominator, divide by 25 power minus x. Otherwise, multiple by 25 to the power plus x, is it? 25 power plus x multiple 25 minus x bases equal at the power answer is 1. Okay, so can I multiple up and down by the 25 to the power x? Okay, so I equal integral, okay, 1 over 9 is to 8 over 9. So here the negative power cancel, 25 only. This one 25 to the power x into 5, okay, and here if I simplify 25 power minus cancel and the 25, okay, say dx, okay. Now what? Can I cut by 25? Simplify by 25. Here 5, here 5, here 5, the cancel. Here this only the answer 25 power x. So I show here, come back to this I equal integral boundaries 1 over 9 to 8 over 9 cut by 5. So 25 5 times, okay. Here cut by 5 cancel 25 power x, right? Plus here 25 5 times dx, okay. Say second equation, second integral part. Now see the board. Common denominator, right? Therefore, I can add simply at the both. These two integrations can be added, right? See, try to add the two integrations and continue to get the collect the answer. Add 1 plus 2, add 1 plus 2, I plus I, 2i, right? 2i equal integral 1 over 9 to 8 over 9, okay. So 25 to the power x here plus 5, okay, over 25 power x plus 5 dx, right? Because the common denominator. Now you can teach me the interesting work. Cancel. All cancel, right? All cancel, then you know the answer 1 dx, 1 integration, right? 2y equal integral 1 dx, boundaries 1 over 9 to 8 over 9. You know 1 integration is x, x differentiation, 1 integration is x, x differentiation is 1, okay. Therefore find the final answer. This is 2y, okay. 2y equal, this is x, boundaries 1 over 9, upper boundary 8 over 9. So what is that? 2y equal, simplify upper boundary minus lower boundary, substitute x4 8 over 9 minus x4 1 over 9, that is 7 over 9, right? So 2y equals 7 over 9. As a result, I equal divide by 2, 7 over 18, right? Here know that arbitrary constant. If there is not definite integration, plus c, but there are no any numerical answer for indefinite integrations. Okay, this is definite integrations. And here the answer 7 over 8. Very useful, a fantastic approach I used. Called the Mr. But King's rule, right? Apply the King's rule and continue. Okay, come back to my next problem. Actually, pure mathematics, I can answer more than one question per video, but I applied only one. Already I shown some one of the statics problem, 3-4 questions. Okay, next problem. How many integer solutions? How many integer solutions to when you solve this inequality x hold? X can collect how many integer answers that been solved. That means they have to solve this inequality. You know, inequality, an important question, every structured paper. Previous question, part of the essay type integration. This is, a structured paper, usually modulus graphs, graphical representation. Can be asked like this also for future. It won't go always same method. Suddenly they change the pattern. Without graph solve can, right? Okay, check your solution. I hope you have completed this one. Okay, you see the above one I write, can use the factorize completing square, x minus 2 all things square, okay, over x plus 2 minus 3 less than or equal 0, right? In a fraction, denominator never comes 0. If comes, so we call indeterminate form. It becomes infinity. Therefore, denominator never 0, right? Okay, see a square. What is a square? Answer 0 or more than 0. X minus 2, all things square, always a positive quantity. Therefore, x greater or equal to, right? So, x can take 2. One solution, x is 2, is it? X is 2 or more than 2. What happened? X is 2, here 0. Here 0, but here there's a value. If x takes 2, here there's a value. So that also satisfies. X is 2, one solution. At the beginning level, I obtained that. Okay. Now see, 2 fraction less than or equal 0, negative. 2 fraction negative, but numerator positive. This is positive or 0. We take positive. Therefore, below part should be negative, is it? X plus 2 modulus negative 3 should be less than 0. Okay. The numerator is less than or equal 0. This is cannot come 0 in fraction, never comes 0. So this part is less than 0. Now solve your basic first day lesson of the modulus inequality in your classes, tuitions or schools or your own. So x plus 2 is, I can solve many methods, the solving by squaring both sides, solve by graphical method, and put the plus or minus symbol. So many methods. So, okay, less than 3. So if I square both sides, more to remove the modulus, square both sides, is it? Square both sides. Can I take the 9 and you can leave it from here also, you can square it, right? So can I use it, the factorization form? It becomes x plus 2 square minus 3 square less than 0. Therefore, a minus b, a plus b, you simplify x plus 2 negative 3 less than 0. So x plus 2 minus 3, other one x plus 2 plus 3, okay, less than 0. That is x minus 1, right? X plus 5, okay, less than 0. So this is the revision class problems. You covered all the theories successfully. Then so this technique. If 2 multiple become less than 0, the answer is between the least and the highest. Between the least and the highest. Okay. Therefore, small value minus 5, large value plus 1. This is the other part of the x value. So if you solve the denominator as a part of inequality, the x solution lies from between minus 5 and plus 1. Or otherwise, you can write, if you were so many methods we use, right? From here I can say modulo x plus 2 more than minus 3 less than plus 3, okay? If any modulus comes this pattern, the answer between minus and plus the values between this. So here also you can find the answer. Okay, check how many solution it has. So here more than minus 5, minus 4, minus 3, minus 2, minus 1, 0. That's all. And also here 2. So 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. There are one 6 values. Is it 6 values? 1, 2, 3, 4, 5, and x is 2 also there. So 6 values satisfies this inequality, right? A super problem using these techniques. So we'll see next time. Another attractive revision paper out series. Definitely one of the questions should be in your future exam paper. That's my target. Please subscribe this my channel. Then you'll receive all the problem day by day to your doorstep. Okay. See you tomorrow.